Hi again, everyone. Dr. Tom McNamara here again for our course in college algebra. We're going to continue our discussion of inverse functions. So in this video, I'm going to do some additional examples of taking a function's formula and finding a formula for f inverse. And another thing we want to do is be able to check that you found f inverse of x. Okay, let's start with a quick example here. Now we're going to do something a little more complicated than what we did in the last video. So let's try this. Let's say given f of x equals 1 over x plus 3, find f inverse of x. So given that f of x equals 1 over x plus 3, find f inverse of x. Okay, so I would recommend you follow these steps in this case. This is a little more complicated. It says you take your input, you add 3, and then you do the reciprocal of that. Okay, so first thing we do, write the function like this. Write the function using x's and y's. Just simplifies our notation a little bit. Now what we're going to do is we are going to switch the x's and the y's. When you write this down, wherever you had an x, turn that into a y. Wherever you had a y, turn that into an x. The reason for this step is that the inverse function switches the roles of inputs and outputs. And of course, remember, when we're dealing with a function, the x's represent the inputs, the y's represent the outputs, and also works on a function's graph too, right? The x coordinates are your input, the y coordinates are your output. Well, the inverse function is going backwards, okay? So the inverse function starts with the output and gives you the input. So we switch them. And then you need to take that and you need to solve for y. All right, so this equation, a little complicated because it involves a fraction. Now, anytime you have an equation that involves a fraction, you can write down an equivalent equation that doesn't have a fraction. So what I'm going to do is I'm going to multiply both sides of this equation by y plus 3. The whole point of that is the y plus 3's on the right cancel each other out. So here's what I'm left with. Notice on the left side I distributed the x to both of the terms in parentheses there, leaving me with this. Okay, now I want to get y by itself on one side. So if this equation is true and I'm looking to get y by itself, here's what I need to do. Okay, I'm going to subtract over 3x. And the rule is I need to get everything without a y to the other side. Everything that does have a y should be on the left. Everything that doesn't have a y, we need to get it over to the right. And now, to get y by itself, I can divide. Okay, 1 minus 3x over x. So this was my function. And that is my inverse function. Okay, so it's a 3-step process. Write your function like this with x's and y's. Switch the x's and y's and then solve for y. Okay, you could still do this with linear functions, it's just that in those scenarios we can usually find f inverse just in our head. Don't try to do that when you have a rational function like this. Okay, do this switch and solve procedure. Okay, let me do a couple more examples for you. Oh, and before we go on to other examples, let me do a little check. Okay, I've got a formula for f, I've got a formula for f inverse. Okay, now let's think about what an inverse is supposed to do. A function takes an input, makes some changes, gives you the output. If you then immediately apply the inverse function, that should undo those changes and get you back where you started. Okay, so in other words, what I want to do is I want to compose f inverse with f and see what that is. Okay, I want to see if this is like basically doing nothing. All right, so I'm going to take f inverse of f. So I'm going to put this entire formula into f inverse. All right, so what does f inverse do? Well, we've got it right over here. And this is another situation where thinking about a function like this comes in very handy. Replace the x's with blanks. Okay, whatever you put over here on the left automatically pops up over there on the right. So if I'm putting this fraction in here, I put that fraction in both places on the right. Okay, so that's what f inverse of f looks like. Now I'm going to try and simplify this as best I can. And what I'm going to do is I'm going to multiply every term by x plus 3. You multiply this by x plus 3, it's just x plus 3. You multiply this by x plus 3, it cancels with the x plus 3 you have there. You multiply this by x plus 3, there's a 1. Okay? Let's make a little note of what we did. So we're multiplying all terms by x plus 3. It's a little technique I like to apply whenever I'm dealing with what we'll call a complex fraction. In other words, a fraction that has fractions in the numerator and denominator. You find the LCD of all the fractions involved, and you multiply every term by the LCD. Remember, the denominator here has just one term. This is one term. The numerator has two terms, that and that. So we multiply this by x plus 3, we get x plus 3. We multiply this by x plus 3. It cancels with the 1 over x plus 3, and we're left with the 3. You multiply this by x plus 3, and you're left with a 1. And of course, in the numerator, I have a plus 3 and a minus 3. Denominator is a 1. Division by 1 doesn't change anything. Just get back what you started with. So we're getting x, which is exactly what we want. That's exactly what we should be getting. So this is saying if we apply f, and then we apply the formula that we found, you get back exactly what you started with, which is what an inverse function is supposed to do. An inverse function is supposed to undo all the changes f made and take you back to the beginning. Okay? That's why they're so useful for solving equations. Okay, so key ideas for this video. That three-step process for finding the formula of an inverse function. So write it with y and x, switch x and y, solve for y. Let me do one more example where we find f inverse. And of course, you can always check if you found the right answer by doing a composition. If you compose a function with its inverse, it should be like you didn't do anything. You should just get the input back again. You should just get the input x. Okay, so in this example, we'll say given f of x equals 2 plus 3, 2x plus 3. Let me throw an x into the denominator and the numerator. 2x plus 3 over x minus 1. Find f inverse of x. Okay, so another rational function, a little more complicated. Last time we didn't have x's up top. Okay, so here's what we do. Start like this. Y equals 2x plus 3 over x minus 1. Switch x and y. Switch them. X equals 2y plus 3 over y minus 1. And now we're going to solve for y. Okay, I want y by itself on one side. Now you'll remember from the last example how to deal with an equation that has fractions. When you're solving an equation that has fractions, clear out the denominators. Multiply both sides by y minus 1. Okay, so we're getting this. All right, now, if that equation is true, that must mean that xy minus x equals 2y plus 3. All right, now, every term that has y, I want that on the left. If you don't have y, you're going over to the right. Okay? So what I need to do is this. Okay? This does not have a y. We're solving for y. No y here, so get away. Go over to the other side. How do you move this over to the other side? Well, you add x to both sides. That'll cancel this minus x here, and you'll get the 3 plus x over there. Why did I move this over to the left by subtracting? Well, this does have a y. So I want all my y terms on that side. Now here's the key step here. We're wanting to get y by itself on one side. Factor out a y. Notice all the terms on the left have a y. Factor out a y. And then, once you've done that, divide. Okay, and that's the expression for our inverse function. F inverse of x is 3 plus x over x minus 2. So it's an application of this three-step process. Write your function like this. Switch and solve for y. Switch x and y, solve for y. And that process will get you the inverse function even in complicated scenarios like this.